In 2016, 3 researchers published a paper in a peer-reviewed journal arguing that the silence of the universe is not absence, it is dormancy. Their names are Anders Sandberg, Stuart Armstrong, and Milan Cherkovich. The journal was the Journal of the British Interplanetary Society, and the argument they set out to defend is that a sufficiently advanced civilization might be deliberately doing nothing at all, holding still, spending nothing, going quiet on purpose, and waiting for the universe to get colder, because when it is colder, thinking will be cheaper. A preprint of the paper went up online the following April, which is where most people have run into it since. I'd like to leave that where it is for a moment without decorating it. It is a real paper. It has a volume number and a page range. It was written by people with academic posts, and a few years later other researchers argued against it in print, in a different journal, carefully and at length. Whatever you end up thinking of the idea, and you have plenty of time tonight to end up thinking whatever you like about it. It isn't a rumor that grew on the internet. Somebody worked it out properly, with numbers, and then somebody else disagreed with the numbers. The first thing worth slowing down for is the word itself. Not hibernation, aestivation. Hibernation is sleeping through the cold, the bear in the den, the winter you have to survive by simply not being present for it. Aestivation is the other one. Aestivation is sleeping through heat, through a season that has become too hot to live in properly, waiting out the summer instead of the winter. The paper carries a small, faintly pedantic footnote about exactly this. Hibernation, it says, might be a more familiar term, but aestivation is the correct one for sleeping through 2 warm summer months. That's the whole footnote. The root is a Latin word, aestus, meaning heat. I find that footnote quietly likable, because you can hear a person in it. Somebody sat with a manuscript about the far future of cosmic civilizations and thought, yes, but the word has to be right. Somebody anticipated the reader who would say, "Don't you mean hibernation?" and answered them in advance, in small type, at the bottom of the second page. And once you notice why the word had to be right, the ground moves slightly, because if you choose aestivation on purpose, you are making a claim about right now. You are saying that the present universe is the too warm season, not warm the way an afternoon is warm. Warm relative to what is coming, and coming slowly, over a stretch of time that makes the whole history of everything look brief. Somebody, in that footnote, is saying that the conditions we live in are the bad season, that we are the summer. That's the first shift of the night, and I'd rather set it down than announce it. Now, aestivation isn't a metaphor that got borrowed from biology and stretched thin. It's a real thing that real animals do, and the best example I know of comes from a museum drawer in London. In March of 1846, the British Museum received a desert snail collected in Egypt. The specimen was treated the way specimens were treated. Identified, glued onto an index card, labeled, and filed away with the rest of the collection. Dead. Catalogued. Done. A small dry shell fixed to a piece of card in a cabinet, in a building full of people whose entire professional lives were the careful study of such things. 4 years later, in March of 1850, the story goes that a curator looking over the shell noticed something that shouldn't have been there. Across the opening of the shell was a seal, a thin membrane, freshly made, of the kind these snails secrete across the mouth of the shell to hold moisture in. It was not old. Something inside had made it after the snail had been glued to the card. So the curator did the obvious thing, which is also, when you think about it, an act of some optimism. He took the shell off the card and put it in warm water, and the snail came out. The record says it lived at the museum for about 2 more years on a diet of cabbage leaves, until it went quiet in the autumn of 1851 and was found dead the following spring. I've only ever seen this account at secondhand, so hold it the way you'd hold any good museum story. But the detail that stays with me isn't the revival. It's the 4 years before it. 4 years of a large institution going about its business a few feet away. Cabinets opened and closed. Catalogs corrected. Visitors shown through. An entire scientific culture, confident, reasonably, that the object on that card was a shell and nothing more. 4 years in a drawer, sealed still, weighing almost nothing, indistinguishable from a dead thing by every test anyone thought to apply, and the whole time it was simply waiting. It wasn't hiding. It wasn't nearly dead. It was doing precisely what its biology tells it to do when the world outside is unservable, which is to stop, seal up, and let the bad season pass over the top of it. The African lungfish does something similar, and, if anything, less believable. When the water it lives in dries out, it burrows down into the mud and secretes mucus which hardens around its body into a cocoon, leaving a tube up to the open air so it can keep breathing. Its internal chemistry rearranges itself for the duration. With no water to flush its waste away, it stops producing ammonia, which would poison it, and starts producing urea instead, which it can safely store inside its own body until the rain comes back. Reportedly, they can hold that state for something close to 4 years. Nothing about either animal is exotic in evolutionary terms. This is ordinary equipment. Life on this planet worked out a long time ago that when conditions are wrong, one entirely sensible option is to stop being active, become indistinguishable from something that has died, and resume later. Dormancy that looks exactly like death is not a strange edge case. It's a solution, arrived at independently, many times over, by creatures with no particular ambitions. So keep the snail on its card and turn to the sky. The universe is old, something like 14 billion years, and it is very large. And as far as anyone has been able to determine, it is quiet. We have been looking in the modest ways available to us for more than 65 years. We have found stars and dust and planets in enormous numbers and no sign whatsoever that anybody is using any of it. That's the whole shape of the problem, and it has been worrying people for a long time. The usual answers come in a familiar set. They are too far away, and the distances are so absurd that nothing ever crosses them. We are early, maybe even first, and the galaxy is simply young. They existed, and then they didn't. Technological life tends to end itself, or gets ended before it becomes visible. Or we're looking wrongly, listening on the wrong frequencies, for the wrong kind of signal. With instruments, a genuinely advanced civilization would find as relevant as a tin can on a string. None of these is stupid. Each of them is held by serious people. The first one, distance, is the one nearly everybody reaches for first, and it is the one with the most give in it, which is worth coming back to. But notice what they have in common. Every answer on that list is an answer about absence. They are not here, or they were not here yet, or they are not here anymore, or they are here in a form so faint it may as well be nothing. The disagreement is only ever about which flavor of missing we're dealing with. The Aestivation paper does something different. And this is the move that makes it worth 2 hours of anyone's night. It doesn't argue that they're missing. It allows that they might already be here in every sense that matters, established, extensive, having arrived long ago and taken hold of a great deal of matter, and simply not doing anything with it yet, present but inactive, not gone. Not late, sealed to the card, in the drawer, waiting. And I should say now, so it isn't a surprise later, that this idea was argued with. Seriously, formally, in print, by people who understood it very well. The identity of the man who led that argument is, to me, the single strangest thing in this entire story, and I'll come to him properly when we've earned it. Set it down for now, because there's a more immediate problem with waiting, and you may already have it in your hands. Waiting costs you. Every year you spend doing nothing is a year of stars burning down to nothing, matter drifting out of reach, opportunities quietly closing. For patience to be the smart move, rather than a slow suicide, the future has to be worth more than the present. Worth so much more that it repays everything the delay destroys. And you can't get that from a mood or a temperament. A physicist won't take patience as a virtue. It has to be a quantity, written down in the same units as everything else. There is such a quantity. It is stranger and smaller than you would expect, and it rests on something that sounds like a question for philosophy and turns out to be a question for thermodynamics, the plain matter of what it costs to have a thought. The ledger can wait a few minutes more, because before anyone prices a thought, there is a door that needs closing, the one still standing open at the back of that menu of answers. As long as it stays open, nobody needs a strange explanation for the quiet sky at all. It is the door most people reach for first, and it deserves to be taken seriously, because it is the most reasonable sounding answer anyone ever gives. They are too far away. Space is too big. Of course it is quiet, and the size is real. Nothing about it is exaggerated. The nearest star to ours is about 4 light years away. 4 years for light itself, which never slows and never stops, and tens of thousands of years for the fastest machines we have ever built. The galaxy is roughly 100,000 light years across. The next real galaxy over is 2.5 million further on. If your instinct says nobody crosses that for a visit, your instinct is doing honest work. But distance is an argument about space, and it quietly forgets about time. The galaxy is not just big. It is old. Most of it has been here for something like 10 billion years, and it has been making stars and planets around those stars for most of that. Once time is allowed back into the picture, the arithmetic changes character completely. You do not need fast ships. You need patient ones. A civilization that drifts out to the nearest worlds, settles in, and a long while later drifts again. No heroics, no meaningful speed, sweeps across an entire galaxy in a few tens of millions of years. That sounds enormous until you put it next to 10 billion. It is a fraction of 1%. On the clock, the galaxy actually keeps. Going everywhere takes an afternoon. That is the old heart of this problem. The part Fermi is remembered for. The question was never whether they could get here. It is that they could have been here 100 times over, with time to spare, starting from almost anywhere. And then in 2013, 2 of the 3 people who would later write the Aestivation paper made the problem as sharp as it has ever been. Stuart Armstrong and Anders Sandberg published a study in a space engineering journal, Acta Astronautica, under the title Eternity in 6 Hours. The 6 hours is not a figure of speech. Their conclusion, stated in the paper's own words, is that only about 6 hours of the sun's energy is needed to commence the colonization of the entire universe. Not the neighborhood, not the galaxy, the universe. 6 hours. The sun pours out an almost unreasonable amount of energy, and nearly all of it streams away into empty space, unused. Gather what it emits between breakfast and mid-afternoon, the paper argues, and you have enough to pay for the start, the initial launch of machinery toward essentially every galaxy that can ever be reached from here. And the start, on their analysis, is the only part that has to be paid for from home, which is why the operative word in that sentence is commence. What gets sent out finishes the job on its own, far away, building what it needs from what it finds. They knew how this sounded, by the way. The paper jokes about a future president of the solar system making the announcement. Everyone turn off your virtual reality sets for 6 hours. We're colonizing the universe. And on one of the author's own websites, the file the paper lives in is named Spamming the Universe. I find those details oddly reassuring. These are people who can hear the absurdity in their own conclusion and who checked the arithmetic and kept it anyway. But notice what this does to the silence. If reaching everywhere costs 6 hours of one ordinary star, and the time required is a rounding error on the age of the galaxy, then distance is finished as an explanation. Crossing the universe is not the hard part. It is worth saying that plainly because the rest of the night leans on it. The quiet of the sky stops being what you would expect and becomes something that needs explaining. The cheaper the trip turns out to be, the louder the silence gets. This is also about the point where a reasonable person wonders whether anyone is allowed to think about such things for a living. And the answer is yes, formally. In the physics literature, with a bibliography. Milan Cherkovich. The third name on the Aestivation paper is the proof. On the paper itself, next to the Institute at Oxford, his affiliation lists the Astronomical Observatory of Belgrade, and in 2003, in the American Journal of Physics, he published something called a resource letter, a field's official map, a guided reading list. Here is what this subject is, and here is what to study, for a discipline called physical eschatology. Eschatology is theology's word. It means the study of last things. Physics borrowed it, without apology and apparently without blinking, for the branch of astrophysics that thinks carefully about the far future of the universe. What happens after the stars And after the things that come after the stars, there is something quietly astonishing in that. And it is not the cosmology. It is the filing. Eternity has a reading list. A man in Belgrade sat down and wrote it, and the Aestivation paper cites it the way any paper cites the standard references of its field. So the silence is loud, and the people listening to it are serious. Hold on to both of those, because the night now turns much older. The shape this paper draws, a great power that is not dead, but sleeping, lying underneath everything, waiting for its moment, is a shape human beings have been drawing for something like 1,000 years. Folklorists call it the king in the mountain, and once you have seen it, you find it all over Europe and beyond. In the lands around Cherkovich's observatory, they told it of Kraljevich's Marko, the hero who did not die, but only sleeps in a mountain. The British told it of Arthur. The Franks told it of Charlemagne. The Danes of Ogier. The Portuguese of their young king Sebastian, lost in battle and never quite believed dead. The details wander from country to country. The shape never does. The king is not gone, whatever you were told. He is under the hill. He will come back when he is needed. The richest version, and let me be clear that this is folklore, told at folklore's strength, no more and no less, belongs to Frederick Barbarossa, the red-bearded emperor. The story goes that he never died. He sleeps inside the Kyffhäuser, a low range of wooded hills in central Germany, seated at a stone table, and he has slept so long that his red beard has grown through the stone of the table. And once every 100 years, the story says, he stirs, not to rise, just enough to send a servant out of the mountain to look at the sky and see whether the ravens are still circling the peak. If they are, it is not yet time, and the emperor goes back to sleep for another century. I want to stay at that table for a moment, because the story is more precise than it had any need to be. A beard grown through a stone table is the story admitting that the weight is not free. Time passes inside the mountain at full weight. It accumulates. It does its slow work. It grows through stone. Whoever added that detail refused the easy version, the enchanted sleep where the sleeper steps out unchanged, and the refusal is the honest part. And the ravens are stranger still. A sleeper who intends to wake needs two things the dead have no use for: a condition, something out in the world that will be different when the time comes, and a way of checking it. One servant, one look at the sky. Once a century. The story worked out, long before anyone could ask the question properly, that the difference between sleeping and being dead is that sleep has an appointment attached. Remember, the ravens. We will be back under this mountain much later tonight, and they will matter more then. And notice which family Barbarossa belongs to. He is another sleeper who cannot be told apart from the dead. The drawer in the museum, the mud at the bottom of a dried pond, and now a hillside in central Germany. From outside, nothing. Grass, trees, birds, weather. The villages below go about their business. The hill never hums, never glows, never gives the slightest sign of the emperor inside, which leaves a question in our hands, and I want to set it down carefully, because it stays with us to the very end of the night. If the paper's version were true, If something vast were lying that still at that scale, somewhere across the sky, what would it look like from here to a small, warm, hurried species with telescopes? I am not going to touch that question until nearly morning. It does have an answer. A real one, the checkable kind, and the sky above your house right now is part of it. For now, just notice what the folklore already understood. The mountain looks exactly like a mountain. So stand back and look at where the problem has ended up. Distance has given way. Getting everywhere is cheap, and the time it takes is nothing against the time available. The other answers were all, one way or another, answers about absence, and the paper's whole opening move was to decline absence. What remains, if they are neither gone nor missing, is a strange and narrow shape, present, capable, and doing nothing, not stuck, not late, waiting. And waiting, chosen, deliberate, at that scale, is not a mood, it is a strategy. The folklore never explains its king's timing. He sleeps until he is needed. And the story asks you not to press the point. A physicist does not get that courtesy. If lying still is the correct move, something has to make it correct. A reason you could write down, plainly enough that a stranger could check the working and try to break it. The paper writes, one down. It comes from a part of physics that has nothing to do with the stars, and it was found by people asking a much smaller question about what thinking actually spends. The answer starts with a fact that sounds like it belongs to a different subject entirely. There is a minimum physical price for forgetting. Erasing one bit of information, one yes or no, the smallest thing a memory can hold, releases a definite minimum amount of heat set by a law of nature, and no machine, however perfect, can pay less. The law was written down in 1961. It was measured in an experiment reported in 2012, and the measurement landed where the law said it would, and the price it names is not fixed. It depends on the temperature of the place where the forgetting happens. Warm places charge more, cold places charge less. That is the whole reason, compressed into a few sentences, and the rest of this stretch of the night is spent uncompressing it slowly. Because everything strange that follows comes out of that one small bill. The man who wrote the law down was a physicist named Rolf Landauer, and he worked at IBM, which matters. IBM built computing machines for a living, so the question of what computation has to cost was, for Landauer, not a philosopher's riddle. It was something close to a question about the electric bill. Machines run warm. Every computer anyone had ever built turned part of its power into waste heat, and the engineering game, then as now, was to shave the waste thinner with every generation. Landauer wanted to know what was underneath the game. Was there a floor? Was there some amount of heat a computation must give off no matter how cleverly the machine is built? Or could a perfect computer in principle think for free? The answer he found has an odd shape, and the shape is the point. It's worth getting exactly right, because the whole rest of the night leans on it. Most of what a computer does turned out to have no minimum price at all. Moving information from one place to another, comparing two numbers, adding them together. None of that has to cost anything, not even in principle. Done slowly enough, carefully enough, those steps can be made as cheap as you please, with no floor beneath them. The floor Landauer found was under one operation only. The operation that cannot be free is erasure. What costs at the very bottom of physics is not thinking. It is forgetting. The reason is lovely, and it deserves a slow minute. A bit is anything that can be in one of two states. A switch that is up or down. A bead resting in the left of two hollows, or the right. When you erase a bit, you take something that could have been in either state and force it into one. You reset it, wipe it, make it blank, which means two possible histories have just been squeezed into a single present. The distinction that existed a moment ago, was it up or was it down, has to go somewhere, because physics at its lowest level does not lose track of anything. So the distinction leaves the memory and passes into the world, and the form it takes on the way out is heat, a small rush of disorder handed from the machine to the room. Erasing a memory is not making something vanish. It is giving it, scrambled beyond reading, to the air. And the price of that little transaction is written in one of the shortest formulas in physics. The minimum heat released by erasing one bit is the temperature multiplied by a constant of nature, multiplied by one more small fixed number, the natural logarithm of 2, a bit under 1, which is in there, because a bit has two possible states. That's the entire law. At the temperature of a comfortable room, it works out to about 3/billionths of a trillionth of a joule. That is an absurdly small amount of energy. Our own machines never notice it. The computers we build are sloppy spenders, wasting heat on a scale that buries Landauer's floor completely. For decades, the number had no practical consequence at all. But the discovery was never about the size of the price. It was about the existence of one. Beneath every possible technology, at the bottom of every conceivable improvement, the universe keeps accounts, and the one entry it always collects on is forgetting. Notice how backwards that is, against everything daily life teaches. We talk about memory as the effortful thing. Remembering is work, studying is work, holding on is work, and forgetting is what happens on its own, for free. The moment you stop paying attention, physics runs the ledger in the other direction. A memory left alone costs nothing. Keeping a bit is free. It simply sits there being what it is. It's the letting go that shows up on the bill. For half a century, this stayed a pencil and paper truth, trusted, taught, but never seen, because the sum involved is so small that catching it in the act seemed hopeless. Then, in the experiment reported in 2012, a team of physicists built the smallest possible act of forgetting and watched it pay. They took a single microscopic bead, suspended in fluid, and held it in a trap shaped like two shallow valleys with a low hill between them. A bead resting in the left valley or the right one bit, made touchable. Then they performed an erasure. They tilted the landscape so that the bead ended up in one particular valley, no matter which one it had started in. Two possible pasts, pressed into one present, and they measured the heat that came off as it happened. As they reported it, when the erasure was performed slowly and gently, the heat released came down to Landauer's floor, and no further. A bill quoted in 1961, presented to a bead half a century later, and paid. So the law is real, in the fullest sense, proposed, derived, and then watched happening in a laboratory. And now look back at the formula, because the part of it that matters tonight is not the constant and not the logarithm. It's the first word, temperature. The price of forgetting is proportional to how warm it is where you forget. Not roughly, not as a tendency, in strict proportion. Halve the temperature, and you have halved the price, and the coldest room on the largest scale is the sky itself. The space between the galaxies sits at about 2.7 degrees above absolute zero, the leftover warmth of the beginning of everything, and at that temperature the toll for erasing a bit is about 100 times smaller than in your bedroom. Nothing about the machine has to change, only the weather. You can begin to see, dimly, why a civilization in no particular hurry might find this interesting. Hold that loosely. It isn't finished, because there is a turn in this story, and it comes 12 years after Landauer, from inside the same company. In 1973, at IBM's Watson Research Center, a scientist named Charles Bennett looked at Landauer's floor and asked the obvious, impertinent question: if erasure is the only thing that costs, if moving and comparing and computing are all free, and only forgetting pays a toll, then could you build a machine that computes without ever forgetting anything at all? And he did not just ask it, he showed, step by step, how it could be done. Bennett's machine works like this. It carries out its computation in the ordinary way, except that it throws nothing out. Every intermediate step, every carried digit, every scrap of working is kept. All of it. When it arrives at the answer, it copies the answer somewhere safe. And then, this is the move. It runs the entire computation backwards. In reverse order, step by step, it undoes everything it did. The last scrap of working unwritten first, then the one before, retracing its own path exactly, until the machine stands precisely where it began, blank, quiet, holding nothing but the copied answer, like a long calculation worked out on a chalkboard, line after line down the board, and then unwritten from the bottom up until the board is clean again. And none of that at any point is erasure in Landauer's sense. Nothing is ever forgotten. At every backward step, the machine knows exactly what it is undoing, because it took that very step itself on the way in. Two histories are never pressed into one. The books stay balanced the whole way through, and so the universe never presents a bill. Bennett had found the loophole in the law of forgetting. Do your thinking, keep your receipts, and then walk backwards out of your own thought, which seems, for a moment, to break everything we just built. If thinking can be done that way, and it can, the logic holds, then thinking is free. Free at any temperature, free in a furnace. And a civilization that can think for free has no reason, on Earth or off it, to wait for the cold. So why isn't the story over? Because Bennett's machine is perfect, and nothing is perfect. I said a moment ago that a memory left alone costs nothing, and that's true. But the world does not leave things alone. Warmth is not a mood. It is motion. Every atom in and around a machine is jostling endlessly at random, and once in a while the jostling wins. A switch gets knocked. A bead gets bumped over its little hill. A bit flips that nobody flipped. An error. And an error is a special kind of event, because it has no history. The machine cannot walk backwards through it the way it walks backwards through its own steps. It didn't take that step, It suffered it and kept no receipt because there was nothing to keep. The only way to fix a flipped bit is to reset it, to force it into the right state regardless of what happened. And forcing a bit into one state regardless of its past is precisely the one operation with a price on it. Correcting an error means erasing it. There is no version of the repair that isn't a forgetting. So a mind that intends to last, through noise, through weather, through deep time, pays after all. Not for its thoughts, for its repairs. The unavoidable cost of thinking at the very bottom is the cost of letting go of what the world scribbles in your margins. And that cost, the one cost that survives every cleverness, has temperature written into it as a plain multiplier. Here the pieces of the night begin to face each other. A patient, careful mind pays only for letting go. Letting go is priced by the warmth of the room, and the room, for anything living on the scale of galaxies, is the sky, which is cooling slowly by our clocks, certainly by any clock. Every degree it loses takes the toll down with it. In step, no exceptions. The same thought, held until later, costs less. Not because the thinker got cleverer, but because the room got colder. That is the reason a physicist could accept, the one you could write down and hand to a stranger to check, granting the paper its one big assumption that the sky is the room where the bill must be paid. Waiting is not just a strategy after all, it is a discount. Forgetting costs, the cold makes forgetting cheap, and the cold out there is only beginning. How deep does that discount eventually run? Whenever this paper gets written about, and it gets written about a great deal, one number always survives the retelling. The claim, and it is the paper's claim, is that a civilization willing to wait could eventually get 10 to the 30th power times more out of the same energy than anyone could get from it today. A 1 followed by 30 zeros. 30 zeros worth of extra thinking from the same fuel, earned by doing nothing but holding still while the universe cools. A number like that sounds like the far end of a formidable calculation. Pages of physics, stacked assumptions, machinery no listener could ever hope to check. It is one division. Here is the whole of it. The price of a lasting thought, really the price of its repairs, the letting go that no cleverness escapes, is proportional to temperature. That much is already on the table. So if you want to know how much better the terms get between now and the deep future, you don't need the machinery at all. You need two temperatures. The temperature of the sky now, divided by the temperature of the sky then. The numerator you already have, 2.7 degrees above absolute zero. The denominator is the new thing. The temperature the sky is headed for. Because it is not headed for zero. That's the quiet surprise underneath the arithmetic. The universe has been cooling since it began. Expansion stretches the leftover light, and stretched light is cooler light. And you might reasonably expect that, given forever, the sky would slide all the way down to nothing. According to the paper, it never quite can. A universe expanding the way ours is has a horizon, a farthest distance beyond which light will simply never arrive here, and that horizon is not perfectly dark. It has a temperature of its own, a glow so faint the word barely applies, but not zero. A lowest possible warmth at empty space, expanding like this, can never drop beneath. A pilot light that cannot be put out. The paper supplies the figure. About 3/millionths of a trillionth of 1 degree above absolute zero. That is the coldest sky this universe will ever offer anyone. Now, divide 2.7 degrees over 3/millionths of a trillionth of a degree. Out comes a 1 followed by 30 zeros. Near enough. That is the entire calculation. The celebrated multiplier, the number that travels everywhere this idea travels, is not the output of exotic physics. It is a ratio of 2 temperatures. It is, quite literally, how much colder it is going to get. Anyone with the 2 figures could do the division on the back of an envelope. And the fact that the answer is astonishing does not make the arithmetic any harder. The paper's most famous claim is, on the paper's own premise about what thinking must cost, a weather forecast. It's worth being honest about the joints here, because they matter later. The division is simple. What it rests on is not. That the toll on forgetting is the bill that binds. That the sky is the room where the bill gets paid is a premise the paper's premisant. And before morning, we will hear what happened when other physicists leaned their weight on it. But grant it for now. The way you grant the rules of a game to see how the game plays. On the paper's assumptions, a thought held until the deep future cost 1/millionth of a trillionth of what the same thought costs tonight. Same thought, same law, different weather, and somewhere in the last few minutes, an objection has probably been forming. Quietly, the way objections do when a deal sounds too clean. If the sky keeps getting colder, and colder is always cheaper, why would anyone ever stop waiting? Whatever you are going to do next year will cost less the year after, and less again the century after that. Follow that logic faithfully, and you never begin at all. It's a familiar shape at human scale. The bottle kept for an occasion that never quite arrives. The savings guarded so well they are never once spent. The authors saw it coming, and they gave it a name that is a small pleasure, all by itself. The paradox of the indefinitely postponed splurge. And the answer has already been laid out. It's the floor. If the cooling went on forever, the paradox would have real teeth. Every possible starting date would lose to a later one without end. And perfect patience would become indistinguishable from never having existed. But the cooling does not go on forever. The sky bottoms out at the horizon's faint glow, and once it is there, the discount is finished. Waiting longer buys nothing further. The gains stop growing, so the postponing can stop too. There is, in this scheme, a last rational moment to begin, so the paper does something almost domestic with the far future of everything. It names dates. 2 of them. They are different dates with different jobs, and they are worth keeping carefully apart. The first comes when the background has fallen to about 100 millionth of a degree above absolute zero. Below that, the paper says, the cost of error correction, the repairs. The one bill nothing escapes, stops being governed by temperature at all. Other, stranger limits take over. Limits that have to do with the grain of matter and energy, rather than their warmth. Past that point, colder no longer helps with the one thing the waiting was for. By the paper's estimate, the threshold arrives in around 270 billion years, roughly 20 times the age the universe has now. Call it the practical alarm. The moment a sleeper worried about the price of repairs would find further patience, no longer paying. The second date is something else. It is when the background itself finally reaches the floor. When the last leftover warmth of the beginning has been stretched all the way down to the level of the horizon's glow, and the long cooling that started with the universe is simply over. That, the paper calculates, comes in about 1.4 trillion years. 100 times the present age of the universe, near enough. And the two dates should never blur into each other, because they answer different questions. 270 billion years is when the biggest single bill stops falling. 1.4 trillion is when the sky itself stops changing. The end of the weather is such. It's the second one that gives the sleep its full duration, so hold it a moment. 1.4 trillion years? Everything that has ever happened. Every star that has formed and burned. Every species that has arisen. Every language, all of recorded history, and the whole unrecorded ocean of time before it, fits inside about 1% of that weight. And what would be waiting on the far side? The paper offers one comparison, and it may be the sentence in the whole thing that you can actually feel. On their assumptions, take just the Earth, not the Sun, not the galaxy, this one small rocky planet, and spend its mass as energy in that cold, far future. And it would power more computation than could be done today by burning the entire observable universe. Everything visible, every galaxy in every direction, converted now, is outthought by one planet, converted then. That is the paper's own claim, resting on the paper's own premise. And in the published text, the sentence ends with an exclamation mark, which is not a punctuation mark physicists spend casually. One planet against everything we can see. That is what the paper means when it says the future is worth more than the present. Numbers like these have, by this point, outgrown their units. 1 trillion years does not mean anything to a nervous system that finds a wet winter long. When the units give out, it can help to reach for older instruments, and there is an old one, as it happens, a way of counting time that was comfortable on this scale long before anyone put a price on a thought. In Hindu cosmology, as the tradition tells it, the universe is not a thing that happened once. It breathes. A single day of Brahma, one working day, in the life of the Creator, lasts a little over 4 billion years, and through it the worlds arise and carry on. And when that day closes, there comes a night of Brahma, exactly as long, called Pralaya, the dissolution. The universe is withdrawn into an unmanifest state and rests. 4 billion years of world, 4 billion years of stillness, and then morning. A day of Brahma, as the old figures have it, is almost exactly the age of the Earth. Very nearly the whole of this planet's 4.5 billion year story, inside a single working day. Nobody should mistake the old reckoning for a prediction. There is no thermodynamics under it, no horizon temperature, no formula anyone was checking. It is not evidence for the paper, and it would be cheap to pretend otherwise. But it is worth noticing, slowly, what that cosmology was already at ease with, that the cosmos might have a night that the night might be as long as the day, that stillness on the largest scale might be neither catastrophe nor ending, but rhythm, the ordinary other half of something that breathes. Those are the very intuitions the paper had to assemble out of equations, held a very long time ago, arrived at another way entirely. Measure the paper's weight in the old unit. Then, 1.4 trillion years comes out to about 324 nights of Brahma, 324 dissolutions, 324 mornings after. And through all of them, in the paper's picture, the sleeper does not stir. One unbroken night of its own, laid quietly across hundreds of the traditions, waiting for a sky that is finally finished cooling. So the question this night set out with has its answer now, whole. Why would waiting ever buy you anything? Because forgetting costs, and the cold makes forgetting cheap. The reason can be written down and handed to a stranger. The size of it, by the paper's arithmetic, is a 1 followed by 30 zeros, and the whole bargain has an ending, a last rational moment out past the 100th lifetime of everything so far. What the arithmetic does not say is what, exactly, does the waiting. All this time the sleeper has been a figure of speech, a civilization, an intelligence, a they. But anything that sleeps through 300 nights of Brahma cannot stay a figure of speech. It would have to be a thing, somewhere, made of something, with a size you could state, a temperature you could measure, a shape lying still in the dark. The paper does not leave it a figure of speech either. It builds one. Part-way through, the paper stops gesturing at civilizations in general and works a single example all the way out, an actual design, with dimensions, so the physics has something to hold on to. And the first thing the design has is a size, a radius of 50 megaparsecs. A parsec is the astronomer's everyday unit of distance, a little over 3 light years. A megaparsec is 1,000,000 of those. A radius of 50 megaparsecs means a body about 1/3 of a billion light years from one side to the other. Not a planet, not a star system, not a galaxy, but something on the scale of a supercluster. Those loose continents of galaxies, thousands of them at a time, that are about the largest gatherings of matter the universe makes. That is what the paper decides to measure. Not a city of minds on some distant world, the distant worlds themselves, in their tens of thousands, gathered up into one cold, still, deliberate thing. Then the paper asks what a body like that runs on. And the answer is the strangest small number of the whole night, 1 watt. 1 watt is a number you already have a feeling for. It is a dim LED. It is the standby light on a television, the glow of a nightlight in a hallway, the kind of light you can sleep next to. In the worked example, that is the operating budget of the entire civilization. A supercluster, idling on the electricity of a nightlight. It can afford to, because of everything the night has already put in place. At that size and that spend, the paper calculates, the body settles to a temperature of roughly 3/100ths of a billionth of a degree, above absolute zero. And down there, the price of forgetting has fallen so far that 1 watt covers almost 4 billion trillion irreversible operations every second. A 4 followed by 33 zeros, near enough, every second, on a nightlight's worth of power. The numbers are the papers, resting on the paper's assumptions. But notice what kind of numbers they are. This is not prophecy. It is a load calculation, the sort of thing an engineer does for a bridge. How much thought can this structure bear? And at what cost? And where the members go? And then comes the number that turns the structure into a body. The paper works out how long a message takes to cross this civilization. One edge letting the far edge know something, at the speed of light, with nothing in the way. The answer is 326 million years, which is the same as the width in light years, and not by coincidence. That is simply what a light year is. But hold the number by its other end. Your own nervous system carries a signal from your foot to your brain in a fraction of a second, and that fraction is part of what lets you be one thing instead of many. For this body, the same errand takes 1/3 of a billion years. Laid on Earth's calendar, an interval that long would begin before the dinosaurs, run through the whole of their era, past its ending, and on through everything that has happened since, with room to spare. That is one reflex, one nerve impulse, crossing one body once. So it seems fair to be uneasy about the word mind here. To ask whether something like that can be one thing at all, or whether it is only a scattered archipelago wearing the word as a costume. But slowness by itself may not be the problem. A mind is allowed to be as slow as it likes, so long as nothing it cares about is faster. And this thing's calendar is the universe's own. A schedule kept in hundreds of billions of years, with the last rational moment more than 1 trillion years out. Against that calendar, a reflex arc of 300 million years is brisk. Nothing it is waiting for will arrive suddenly. The cold at once comes on like a tide, and the tide holds no surprises. A creature matched to that rhythm would not experience itself as slow, any more than we experience our own thoughts as a lag. It would simply be the pace at which being this thing happens. The paper also asks what this body's memory is made of, how finely a supercluster's worth of matter can be divided into reliable bits. At the deep future temperatures the design is meant for, the limit comes out near a 1, followed by 75 zeros. And here, the paper adds a detail almost nobody quotes. Each of those bits could be up to 13 centimeters across. 13 centimeters, the size of a grapefruit. A memory 1/3 of a billion light years wide, whose individual switches you could hold in one hand. There is a catch, and the paper is candid about it. Bits in that number would have to be lighter than electrons. Lighter than the lightest pieces matter actually comes in, and matter declines to cooperate. It is grainy stuff. It arrives in lumps, and the phrase the paper uses for this, in the middle of all its eternity, is matter chunkiness. Allowing for the chunkiness of matter, the practical ceiling comes down to a 1 followed by 69 zeros. And at today's warmth, under our familiar 2.7 degrees above absolute zero, the same supercluster would hold only about a 1 followed by 61 zeros. Only, of course, is doing unusual work in that sentence, but the direction is what matters. The ceiling itself rises as the sky cools. The discount the night keeps returning to does not just make thinking cheaper, it buys more room to remember in. The hardware improves by lying still, untouched, in the dark. It is worth pausing here to ask whose imagination works like this. The paper's first author is Anders Sandberg, the first name on the paper whose mildly pedantic footnote taught the word aestivation near the start of the night. The story told about him is that he came to Oxford's philosophy corridors, not from philosophy but from computational neuroscience, from years spent modeling how memory settles into networks of neurons, and that in his spare time he helped found a collaborative science fiction project in which many hands have spent years building one enormous imaginary future together. If the biography is right, it explains something about how the paper reads, thermodynamics, and questions of value in the same document. A man who studies how minds hold on to things and who builds whole worlds for practice. And in the Aestivation paper itself, down in a footnote, there is a moment that could belong to no one else. He pauses, mid-argument, to cost out enclosing a galaxy the size of the Milky Way in a balloon of graphene, works the estimate through, finds the balloon alone would weigh nearly 2 million times the mass of the Sun, and concludes that it is probably not worth it. He priced the bagging of a galaxy the way you might price a roof repair, and noted that the quote came back high. The whole hypothesis has that temperament running through it. Enormous, patient, and oddly practical. A filing clerk's calm applied to eternity. Notice, too, and this is worth setting down carefully, because the night comes back to it near morning. What a body like this would offer a telescope. 1 watt, spread across a supercluster. No engines, no beacons, no waste heat worth the name. Hundredths of a billionth of a degree. Nothing bright, nothing warm, nothing that moves. On any time scale a human lifetime could notice. From here, a sleeper like this would look almost exactly like nothing at all. Like a stretch of sky where nothing much is going on, which is either a coincidence or the whole point, and the difference between those two turns out to be a question with a checkable answer, still waiting where it was promised. There is one more number, and it belongs on the far shelf, so it should be labeled before it is lifted down. Everything so far has been the paper's worked example, the illustrative case, the reasonable middle of the range. But the authors also follow their own logic out to the absolute limit of what physics allows, and they are explicit that this is what it is. Not the central scenario, not what they expect, not a prediction of any kind. The outermost case the equations permit, the wall you reach when nothing more can be squeezed. In that limiting case, the civilization has cooled essentially to the floor itself. The horizon temperature the night can never drop beneath, and it spends almost nothing at all. A wattage that begins with a decimal point, then 74 zeros, and then a 1. In exchange, across the whole deep future, it gets a 1 followed by 115 zeros. That many separate acts of forgetting, the most the universe will ever hand anyone. And then the sentence, the paper's own, which almost nobody quotes. In that extreme case, each bit erasure, when it happens, causes what the authors call a hiatus of 100 quadrillion years. A 1 followed by 17 zeros, millions of times the present age of the universe. Between one act of forgetting and the next. Be slow with that. A machine that pauses for 100 quadrillion years is a machine that has failed. Some switch stuck, some clock run down, some project abandoned by whoever was meant to care. But nothing here has failed. In the picture the paper is drawing, at the limit, on its own assumptions, as the extreme case and never the plan. Everything is proceeding exactly as designed. It is simply that at the outer edge of the possible, the design breathes at the pace of the dark. One small letting go, then a wait longer than the age of everything, millions of times over, then another letting go. That is not a machine that is asleep. That is a mind whose thoughts are further apart than the whole of the past. So the sleeper has its body now, whole. A width of 50 megaparsecs, a third of a billion light years. A budget of 1 watt. A memory whose separate pieces you could hold in one hand. A reflex 300 million years long, and, out at the very limit of what physics will allow, thoughts spaced 100 quadrillion years apart. Nothing about it is a figure of speech anymore. It is the posture the night began with in a museum drawer. Sealed, misread, patient, grown to the width of a supercluster, and laid out across the dark. Nothing wrong with it, nothing hurried in it. Lying exactly where the arithmetic says a careful thing would lie. Waiting for a sky that suits it. It would be natural to assume that a picture like that was invented all at once, about a decade ago, by the 3 people whose names are on the paper. A mind lying down across 50 megaparsecs sounds like the kind of thing that has no ancestors. But the paper itself never claims to be first, and it admits as much in the quietest place. A paper can admit anything. The reference list at the end, where every scientific idea has to show its family. The second item on the Aestivation paper's list is older than most of the people who will ever read it. A paper from 1979, 37 years before, called Time Without End. The idea of sleeping through the expensive stretches of eternity was not new in 2016. It was nearly 40 years old, and it belonged to Freeman Dyson. Dyson deserves a moment. He was a physicist at the Institute for Advanced Study in Princeton, one of the great unclassifiable minds of his century. If you have ever heard of a Dyson sphere, the notion of wrapping a star in collectors to catch its entire output, that is the same Dyson. And in 1979, he published a set of lectures in a physics journal, asking, with complete seriousness, what happens to life in the very long run? Not life on Earth, life as such, anywhere, over spans of time in which the stars die and matter itself begins to tire. The field those lectures opened is the one we met earlier. Physical eschatology, the physics of last things. And Dyson's opening move is still the best sentence in it. It is impossible, he wrote, to calculate in detail the long-range future of the universe without including the effects of life and intelligence. Astronomy had always treated life as a passenger, something that happens on the surface of the real story, while the real story gets on with its stars and its gravity. Dyson's sentence promotes life to a term in the equations. Whatever the deep future turns out to be, he was saying, it will have minds in it, and a forecast that leaves the minds out will simply get the future wrong. His deep future, though, was a different shape from the one this night has been describing. Dyson was writing before anyone knew the expansion of the universe was accelerating. In his picture, the cosmos simply cools, forever. Every age colder than the one before, without limit and without a floor. And his question was whether thought must end there. Given endless cold and a finite stock of energy, can a mind keep going forever? Or does the last thought eventually come for everyone? His answer was that the last thought never has to come. And the trick he found is the ancestor of everything we have walked through tonight. Hibernation, life, he wrote, may metabolize intermittently, but may continue to radiate waste heat into space during its periods of hibernation. Naps, in other words. A civilization thinks for a while, then shuts down, lets its accumulated heat drain away into the dark, wakes, thinks again, sleeps again. And because his universe keeps cooling, each sleep lets the next stretch of thinking run a little cheaper than the one before. Push that pattern out to infinity and something remarkable happens. The total energy needed for an unending future of thought stops being infinite. Dyson worked out the budget for a society of human complexity to carry on this way forever. Literally forever. Thought without end. And his own gloss on the answer is the part worth keeping. It comes to about as much energy as the sun radiates in 8 hours. Earlier in the night, we met 6 hours of the sun as the entry price for beginning to take the whole universe. Here is 8 hours of the sun as the running cost of thinking until the end of time. The two figures come from papers written a generation apart by different people about different questions, and there is no deep reason they should land so close together. But it is hard not to notice that on the scale of what a star gives away in a single working day, both eternity and everything turn out to be affordable. So, the strategy is old. What is new is the direction it runs. Set the two designs side by side, and they are the same idea built the other way round. Dyson's sleepers nap repeatedly, forever. Sleep, wake, think, sleep. An endless alternation, the naps growing longer, and the waking spells thinner as the cold deepens. Thoughts stretching out like a note held longer and longer, but never stopping, never finishing. In his forever cooling cosmos, tomorrow is always cheaper than today, so there is never a reason to spend everything now. And the wise course is to dole eternity out to yourself in ever smaller sips. The Aestivation paper's sleeper does the opposite. One sleep, one long consolidated stillness. From now until the sky reaches its floor, and then one long waking, in which the whole budget is finally used. Dyson's beings ache an infinite future out of a dwindling purse. The paper's sleeper is a saver with a date in mind. And the reason the two designs differ is not that one of them made a mistake. They were drawn under different skies. Dyson's universe, the one he assumed in 1979, cools without limit, which means the discount on thinking deepens without limit, which means the right move is never to cash out at all, only to slow down gracefully forever. Then, nearly 20 years after his lectures, astronomers discovered that the expansion of the universe is accelerating, and the acceleration put a floor under the cold, the pilot light from earlier in the night, the faint horizon glow that never goes out. A floor changes the whole strategy. If the price of thought bottoms out, then there is a best temperature, a last discount, a final morning actually worth waiting for. And the right design is no longer an infinite dwindle, but a single sleep aimed at a single date. In a sense, the Aestivation paper is Dyson's strategy revised for a sky with a bottom. The nap became a night's sleep because the cold acquired an end. Even the words the two papers chose tell you this. Dyson called his strategy hibernation, sleeping through cold, and for his endless winter, that was the right word. The 2016 authors, remember the footnote from the start of the night, insisted on Aestivation, sleeping through heat. Same strategy, opposite season. In Dyson's picture, life sleeps because the universe is growing cold around it. In the paper's picture, life sleeps because the universe is still too warm, because now, this bright burning era is the bad season, and the good one is the long cold to come. Between 1979 and 2016, the sleep changed seasons without ever changing its nature. Hold on to that reference list, by the way. It has just given us the idea's ancestor. Before the night is over, it will give us the idea's sharpest critic, the man we were promised at the very start, whose identity is the strangest thing in this whole story. He is in the list right now, cited among the paper's own foundations, waiting the way everything in this story waits. That is still a little way off, because the list holds neighbors as well as ancestors. Reference 40 is a paper from 2003 called Astronomical Waste by the philosopher Nick Bostrom. And Bostrom was not writing from across the world or across a century. He worked at the same institute as the Aestivation paper's authors, in the same building in Oxford. The office next door, more or less. And his paper argues, with great force, for what sounds like the exact opposite of everything this night has been saying. Bostrom's subject is the cost of delay, all the while that a civilization is not out there gathering the universe's resources and putting them to use. He argued, those resources are draining away, stars burning their fuel off into empty space, energy nobody will ever get back. And that loss can be counted in the only currency he thought ultimately matters. Lives that could have existed and now never will. His numbers need their caveats spoken in the same breath. And it is a caveat he makes himself. They belong to the scenario in which future minds are computational. People running as software on all that gathered matter. The same assumption underneath the Aestivation papers own enormous futures. On that assumption, Bostrom calculated that every century we delay the colonization of our local supercluster, the potential for roughly a 1, followed by 38 zeros human lives, is lost. Every century. Or brought down to the scale of a held breath, about a 1 followed by 29 zeros potential lives per second. And if you set the digital assumption aside entirely and count only ordinary biological people living on ordinary planets, his deliberately cautious version still comes out at over 10 trillion potential human beings lost for every second of delay. The unit is worth noticing first, the local supercluster, the same width of world our sleeper's body was measured in. And then the collision. One office in that Oxford building says that every single second of waiting costs more potential lives than there are people alive on Earth today, 1,000 times over even on the most cautious counting. The office next door says the correct move for a mature civilization is to lie down and do nothing for 1 trillion years. Waiting is the great catastrophe. Waiting is the great strategy. The two claims pass each other on the stairs. You might expect the Aestivation paper to treat that older argument as an enemy, or at least to tiptoe around it. It does neither. It cites astronomical waste directly and says something unexpected. On the paper's picture, Bostrom's argument does not get weaker. It gets stronger because the stakes have gone up, and once you see how the two fit, the tidiness is genuinely satisfying. Bostrom's clock punishes delay in claiming. Every second the universe's matter sits ungathered. Some of it is wasted beyond recovery, and every wasted gram is futures lost. The Aestivation strategy agrees completely. That is why its civilization moved early and fast. 6 hours of sunlight to begin. Everything gathered and quieted long before the sleep. The sleep is not the delay Bostrom condemns. The sleep comes after the claiming, and it is precisely what makes the claiming worth so much, because patience multiplies what every gathered gram can eventually become. By that factor from earlier in the night, the 1 written as a 1 followed by 30 zeros. And if patience raises the value of matter by that much, then wasting matter now is by that much worse. The two arguments are not rivals. They are two halves of one motion. Hurry, so that you have something to be patient with. Be patient, because that is what the hurrying was for. Sandberg himself put it in the plainest terms. The Aestivation paper, he said, gives some new numbers to feed into Nick Bostrom's astronomical waste argument, not a rebellion against the office next door. A supply line to it, so the knot unties. The sprint and the stillness turn out to be one plan. Expansion first, at whatever speed physics allows, then the long lying down, then the spending. Dyson's endless naps, the paper's single sleep, Bostrom's furious arithmetic of delay. All of them, underneath, are ways of taking the future seriously as a place where value actually lives. It is a tidy resolution, and it deserves the word without irony. Both papers stand. Both offices were right, each about its own half of the motion. But every plan of this shape, sprint, then sleep, then spend, rests its full weight on one small hinge in the middle, an assumption so plain that neither office seems to have spent much ink on it. Sleep, everywhere we have found it tonight, is only a strategy if it ends. The whole design assumes, quietly, the way load-bearing assumptions are always quiet, that when the last cold morning finally arrives, something wakes. 17 years before the Aestivation paper was written, 2 physicists had already picked that hinge up and turned it over in the light. Their names were Krauss and Starkman, and the paper they wrote together carries one of the bleakest titles in the physics literature: Life, the Universe, and Nothing. You can hear where the argument is going just from the words. They were auditing Dyson's old plan, the endless naps we walked through earlier tonight, the intermittent forever, and asking whether a mind with a finite supply of energy and a minimum rate of spending really could stretch itself across eternity. Somewhere in the middle of that audit, they wrote down the one objection in this whole story that has nothing to do with thermodynamics. They granted the strategy its logic first. Faced with a minimum rate of energy consumption and a finite energy supply, they wrote, "Increasingly long hibernation seems the obvious alternative. But this requires perfectly reliable alarm clocks." And then the sentence that the rest of tonight has quietly been walking toward. Statistically, all alarm clocks eventually fail. It is worth sitting with what an alarm clock even means at this scale, not the thing on a nightstand. Whatever wakes a sleeping civilization has to be a mechanism, a physical thing, made of matter, sitting out in the cold with one job. It has to keep something like time, or watch something like a temperature, across a span in which stars finish burning and galaxies finish falling into one another. It has to work, unattended, for longer than everything that has ever worked has worked, and it is made of the same stuff as everything else. It has parts. Parts fail. Krauss and Starkman were specific about how. Over stretches of time that long, the failures do not need a cause in the ordinary sense. No rust, no dropped screw. At very low temperatures, they wrote, the failures may be statistical or quantum mechanical, which means the mechanism can be built perfectly and fail anyway, because given enough time, unlikely stops meaning much. A thing that fails once in a trillion years is, on the calendar this civilization has chosen for itself, simply a thing that fails. Duration is the whole strategy, and duration is exactly what turns rare into certain. And then they followed the thought to its end. In one sentence, I want to leave a little room around. In the absence of a sentient being to repair the broken alarm clock, hibernation would continue forever. Continue forever. Notice what that means and what it does not mean. Nothing dramatic happens. There is no collapse, no catastrophe, nothing a distant observer would register at all. The sleeper simply stays exactly as it is, doing exactly what it was doing, which is nothing, while the one morning the entire design was pointed at arrives and passes unmet. Everything tonight has turned on the fact that deep dormancy looks exactly like death from the outside. Here that fact turns around and shows its other face. If the clock has failed, the stillness afterwards is identical to the stillness before. No signal changes, no light comes on, and there is no one inside to notice, because not being anyone, for a while, was the plan. The failure would be perfectly silent, including to the thing it happened to. You can feel the argument close around itself. The obvious repair is a repairman. That is exactly the word the objection uses. A sentient being, someone awake enough to notice the clock has stopped and fix it. But the entire design is that nobody is awake. That was the whole point. Wakefulness is the expense the sleep exists to avoid. Keep a mind on watch and you have broken the sleep. Something is up, thinking, spending, running the very meter the civilization lay down to stop. Make the watchman a machine instead, and you have not solved anything. You have built a second alarm clock, and statistically, all alarm clocks eventually fail. You can hand the job downward as many times as you like. Every hand you give it to is made of matter, sitting in the cold, waiting to fail in its turn. There is one more turn, and it is the coldest one. Because the natural instinct is engineering, build the clock sturdy, shield it, wrap the sleeper up safe. Krauss and Starkman had thought of that too. And what they noticed is that the physics runs the wrong way. Staying in thermal contact with your surroundings, they pointed out, actually suppresses the fluctuations that would otherwise, eventually, kill you. The warm world jostles whatever sits in it, and the constant small jostling strangely steadies things. It keeps the rare large accident damped down. And then their next words, however, hibernation requires precisely the opposite. The whole strategy. Everything we built up through the middle of tonight works by decoupling. Unplugging from the warm bath works by decoupling. Unplugging from the warm bath, drifting free of every source of noise, because noise at temperature is exactly what thinking pays for. The sleep is cheap precisely because nothing touches the sleeper. And nothing touching the sleeper is precisely the condition in which the deep, patient, quantum accidents get their chance. The blanket this civilization must throw off in order to sleep is the same blanket that was keeping watch over it. What makes the sleep affordable is what makes the waking uncertain. It is not two problems. It is one problem seen from its two sides. Maybe the easiest way to feel the weight of this is to notice how we do it, how you are doing it. More or less right now. You can afford to fall asleep tonight because you have quietly hired the entire world as your alarm clock. Light will come through the window. The temperature will change. Sounds will start up in the street. And there are other warm people who know where you are and will come looking if you stay down too long. You sleep inside a system that wants you back, and that is why letting go feels safe. The letting go is real, but it is held. The Aestivation civilization has, by design, fired the world from that job. It has cooled itself out of reach of every hand that could shake it. The better it sleeps, the farther it is from anything that could ever wake it. That is not an unlucky side effect. That is the definition of how the sleep works. Followed all the way down, the strategy asks for something we have never once seen, a letting go that is held by nothing. Now, I have to be honest with you about where this objection stands, because the honest answer is the strangest part. The Aestivation paper knows the Krauss and Starkman paper well. It sits right there in the reference list, entry 6, and the authors clearly read it with care. They even answer one of its worries directly. A technical concern about the radiation that leaks in from the horizon of an accelerating universe, and the paper says plainly that its temperature floor resolves that problem the two of them had pointed out. So this is not a case of an objection nobody saw. They saw the paper, they engaged with the paper, and they go further than that. There is a passage in the paper that takes up whether the machinery left standing through the long dark would last at all, whether the guards hold, and it answers yes. Keep backups, and backups of the backups, added patiently enough. And the chance of losing everything need never harden into a certainty. It is a careful answer, and it is an answer to a real worry. But look at what it is an answer about. It is about whether the sleeping thing is still there in the morning. It is not about the morning arriving. The one question, the simple, human, unanswerable sounding question of what wakes you when everything that could wake you has been turned off. I have looked, and as far as I can find, the Aestivation paper never comes back to it. Not where the paper answers the objections. Not in a footnote, and this is a paper that likes footnotes. Perhaps the authors have an answer they never wrote down. But the page is where arguments live, and on the page the sleeper is preserved beautifully, and nobody is sent to check the ravens. So I want to set this one down differently from every other question tonight. Everything else we have opened has been answered, or will be before morning. This one will not be. I am not building toward a hidden resolution, and I would rather tell you that now than let you listen for a click that never comes. There are more arguments still ahead of us. One big one, the one I have been promising since the first stretch of the night. And I will tell you plainly, it is not an answer to this. It comes at the sleeping civilization from a different direction entirely. And when we get there, the alarm clock will still be sitting here, unanswered, exactly as it has been for a quarter of a century. Some questions in this story are open because nobody has gotten to them yet. This one seems to be open because it is genuinely hard, and it is allowed to just stand there. An open question honestly labeled is a restful thing to fall asleep beside. But there is a sadness in it, and I do not think we should pretend otherwise. It is the sadness of a sleeper that can never safely stop listening. Hold both halves at once. Keep one ear open across eternity, and you were never fully asleep. Something in you stayed up all night, every night, for 1,000,000,000,000 years, paying the warm price the whole scheme was meant to escape. Close both ears, let go completely, and the sleep becomes perfect and perfectly cheap, and may simply never end. The middle path is the one the physics seems to begrudge. Our own sleep, every night of our lives, is a small act of trust. Trust that the world will still be there, and that it will come and get us. Stretch that trust across forever. Subtract the world from it, and it stops being trust at all. It becomes a wager, placed once, that no one is holding the other side of. Somewhere in the middle of tonight, waiting looked like the cleverest thing a civilization could do. It still might be, but it is no longer just clever. It is also the largest gamble anything has ever taken on the reliability of an unwatched machine. And so we are back under the mountain. I told you hours ago, now, that we would be, and that the ravens would matter more when we returned. Here is why. The old story got to keep its emperor only by adding 2 details it never explains and never gives up. The beard that has grown through the stone table is the first, the admission that inside the mountain time keeps charging full price, that everything down there is aging, including, though, the story never says it aloud, whatever is supposed to do the waking. And the second is the servant. Once a century, the check sent out to see whether the ravens still circle the peak. The story has no idea what stirs the emperor at each 100-year mark. It never even asks. It just refuses, flatly, to let him sleep unattended. Centuries before anyone could write the physics down, the tellers already seemed to know that a sleep with no one watching it is not a sleep you can promise will end. The servant is not decoration on the legend. The servant is the hard part. And Krauss and Starkman only found the numbers for what the story already knew. When the formal argument finally came for the Aestivation paper, printed, peer-reviewed, with the strangest name in this whole story at the top of it, it was not about the alarm clock at all. It came from a different side entirely. The ravens, for now, keep circling. The argument was published in 2019 in a journal called Foundations of Physics. It took the form that physics reserves for organized disagreement. A comment, which is a short paper whose entire purpose is to answer another paper, printed in the open, where the whole field can watch. 3 authors, and the first name on it, the name at the top, was Charles Bennett. The same Charles Bennett, IBM's Watson Research Center. The affiliation is right there on the rebuttal, the same institution he was at in 1973 when he found the loophole in the law of forgetting. The man who showed that a machine could think for free if it kept its receipts and then walked backwards out of its own thought. You have already met him, and so has the Aestivation paper. Not casually, not in passing, but structurally. Go to its reference list, and he is there at number 18. Bennett, 1973, Logical Reversibility of Computation. The entire sleeping scheme stands on that result. Without the backwards walk, there is no cheap thinking. Without cheap thinking, there is no reason to wait for a colder sky. Without the colder sky, there is no hypothesis. Take Bennett out of the foundations and the whole patient edifice sits down in the dust. And the first author of the paper arguing against it is Bennett. That is the strangeness I promised you at the very beginning of the night, when I said the identity of the man who led the argument was the strangest thing in this whole story. Not a rival from some enemy camp. Not a passing skeptic looking for a target. The foundation itself, standing up and saying, "You have built something on me that I do not think I can hold." It would be easy to hear that as an ambush, and it is closer to the opposite. Think about who is actually qualified to say what reversible computing can and cannot buy as civilization. The answer is the person who invented it. Bennett never really left that loophole. The rebuttal's own reference list leans on a review he wrote back in 1982, titled, plainly enough, The Thermodynamics of Computation. When a tool you made in 1973 turns up 4 decades later, holding the weight of a sleeping universe, you are perhaps the one person on Earth with both the right and the duty to check the load-bearing math. In a healthy field, your foundations read you. The reference list we called a family earlier tonight behaved exactly the way families do. It wrote back, and the second name on the rebuttal deepens the family resemblance. Robin Hansen. His name was already in the Aestivation paper too. Not in the references this time, but in the acknowledgments. That small paragraph near the end, where authors thank the people who sharpened their thinking. 11 names are listed there, thanked for helpful and stimulating discussion, and Hansen's is among them. Note the precision of what that means, because it is a nice fact, and nice facts get inflated. He did not help write the paper. He was thanked for discussion. He was in the room, or at least in the conversation, while the idea was being worked out, and 2 years after the paper appeared, he surfaced on the other side of it, second author of the Objection, alongside Bennett and a third author named Jess Riedel, which tells you the conversation never actually ended. It just went quiet for 2 years, and then came back in print. So, what did the 3 of them say? Not one word about waking up. Their objection aims at the engine room, at the pricing, the very heart of the machinery we spent the middle of tonight assembling. And, it can be said in a single sentence, the sky is not the only bin. Everything in the sleeping argument treats the sky as the place where waste must go. That was the quiet assumption underneath every number we touched. The cosmic background is the universe's one rubbish bin for entropy, its temperature the posted price of forgetting, so that a civilization wanting cheaper erasures has exactly one option, which is to wait for the bin to cool. Bennett, Hansen, and Riedel looked at that assumption and pointed at everything else. The universe, right now, is full of things that are not in equilibrium with each other. Hot stars and cold dust, dense here and empty there, unevenness everywhere you look. And any two things that are out of equilibrium, any difference at all, can be made to absorb entropy. You do not need the whole sky. You need a difference. Their example is almost domestic. Take some inert insulating matter, nothing exotic, just material that will hold still and build a box. Let it fill with the same background radiation that is outside it. Now you have two reservoirs whose temperatures are not quite the same, and between two reservoirs at different temperatures you can run an engine. A careful, reversible engine that soaks up the cost of your erasures as it goes. When that difference is spent, build another box. Repeat. In their words, for as long as there is any matter in the universe accessible to the civilization, erasure paid for not by the sky, but by unevenness itself. And unevenness is not something the far future has more of. The present is rich with it. Their conclusion is stated with a lawyer's care. A civilization can freely erase bits without giving up larger future rewards. Quote, up until the point when all accessible bounded resources are jointly thermalized, which is a cold-blooded way of saying something enormous. If they are right, the discount we spent all night deriving was never a discount at all. The thinking does not get meaningfully cheaper later, because it was never actually priced by the sky. You could always mint your own cold, box by box, difference by difference, starting today. On their model, the reason for the long sleep simply goes quiet. Not the physics of Landauer's price. That stands untouched. But the argument that you must wait out the warm season to afford your thoughts. If any difference is a bin, the summer was never too expensive to think in. Notice the shape of that sentence. If they are right, hold on to it. We are going to need it. But first, one small thing from the bottom of their paper, because it tells you what kind of disagreement this actually was. The rebuttal's very last reference, the final footnote of the whole document, is attached to the word estivate. It notes that the authors prefer the proper American spelling, estivation, without that antique extra letter at the front, but that they will defer to the original paper's British convention and, quote, save our spelling criticism for a different venue. 3 researchers, in the middle of dismantling the thermodynamic basis of a trillion-year sleep, reserved their last footnote for a joke about the letter A. People do not write footnotes like that about enemies. They write them about colleagues. And they behaved like colleagues in a more substantial way too. Before the rebuttal was published, its authors wrote to Sandberg, the man whose paper they were about to argue against, and asked him in effect, have we understood you correctly? Their paper records his answer, thanking him for confirming that their summary of his argument was a fair one. Sit with that for a second. They checked with their opponent before opposing him. The argument was conducted the way you would want every argument on Earth to be conducted, and almost none are. So who won? Nobody won. I want to say that carefully, because it is not a diplomatic evasion. It is the actual, checkable state of the record. No published reply from Sandberg, Armstrong, or Cherkovich has ever appeared. None has been found, anyway. There is no counter-comment sitting in a journal. No second round in print. What exists instead is email. Riedel has written on his own blog that Sandberg and his colleagues did respond. In personal correspondence, advancing physical arguments for their assumption involving, of all things, black holes. And Riedel's reaction, in his own words, is a small masterpiece of honest uncertainty. The arguments don't smell right to him at all, he says, but they are almost impossible to assess because he has not yet seen them presented thoroughly. That is where the frontier of this question actually lives. Not in a verdict, but in a physicist saying of his opponent's unpublished counter-argument, "I don't believe it, and I can't yet evaluate it." And here is the part that does the most credit to everyone involved. The rebutters hedge their own side, too. Their paper concedes, in print, that it is unclear whether their conclusions survive a more realistic model of the universe. They even flag a specific technical subtlety, a matter of counting the modes of the background radiation, which, they write, may invalidate conclusions drawn from this crude model. Crude is their own word for their own reasoning, and the sentence goes on to say that this subtlety could moot both the original arguments and their rebuttal alike, both sides sunk by the same wave. The men who wrote the objection are telling you, unprompted, that the instrument they use to object may be too blunt to decide the question. So the honest standing of the Aestivation Hypothesis, tonight as you lie there, is this: proposed in print, argued against in print, by the very people whose work it stands on, defended by private email, and open, disputed, and unresolved, and being carried at whatever slow pace ideas move when almost nobody is paid to care about them, by a handful of people who write to each other carefully and admit what they cannot yet show. And then, at the very end of their paper, the three critics do something almost nobody who cites them ever mentions. Having spent their pages arguing that no one needs to sleep until the end of the universe, they close with a speculation of their own. It has not escaped our notice, they write, and that phrase is an old, knowing one in science, the phrase you reach for when you want to tuck your largest thought into your smallest sentence. It has not escaped our notice that dark matter, whose nature remains a mystery, may have a purpose for a powerful civilization able to produce it. The purpose: to temporarily sequester most of the mass of the universe, to park it in a form whose dynamics conserve energy, angular momentum, and very nearly entropy itself, until it can be most expeditiously converted back into ordinary matter whenever it is wanted. Not a bedroom for a sleeping mind, a savings account. The missing majority of the universe, on this idle closing thought, is not missing at all. It is deposited. And then, the last sentence of the speculation, which is the warmest sentence anywhere in this entire literature. One might hope, they write, that such a civilization would preserve a few of the stars, The supernovae as a grand public art project. Beautiful, possibly controversial, and consuming only a small fraction of all resources. The men who took the sleeping civilization idea apart and their paper, hoping that whoever owns the universe left some of the stars up for the view. Whatever else the two sides of this argument disagree about, and they disagree about nearly everything that can be written down, they end in the same posture, looking up at a sky full of burning, extravagant, unthrifty lights, and finding it worth keeping. Somewhere in all of this, it is worth saying what the man who proposed the hypothesis actually thinks of it. Anders Sandberg keeps a page on his own website about the Aestivation paper. A plain outline written for people who would rather not read the equations, with a list of questions he imagines being asked, and his answers underneath. One of the questions is the one you would most want to put to him, and he puts it to himself in exactly the words you would use. Do you really believe in it? And his answer, in his own words, I personally think the likeliest reason we are not seeing aliens is not that they are estivating, but just that they do not exist or are very far away. That is the author. That is the first name on the paper, saying in public, on his own page, under a heading he wrote himself, that he does not think his own hypothesis is the likeliest answer. Nobody caught him out, nobody pressed him. He offered it. And then he says why he built the thing anyway, and the reason turns out to be better than belief would have been. Because, he writes, we need to cover as much of possibility space as possible. Possibility space, not the space of what is true. Nobody holds that map, but the space of everything that could be true, laid out edge to edge, so that when evidence finally arrives, it has somewhere to land. Most of that territory is ordinary. They are not there. They are too far. We are early. And out along one strange coastline lies a region almost nobody had surveyed, where the silence is not absence, but timing. And Sandberg and Armstrong and Cherkovich spent a piece of their finite lives walking its border and writing down, carefully, what would have to be true for anyone to live there. Not because they expected anyone did, because an unmapped coast to a certain kind of mind is a standing reproach. That changes how the whole night sounds, I think. The question was never really, is it true? The question was, what would it cost? And what would it look like? And has anyone checked? And those questions got answered beautifully, even though the first one didn't. Surveyors don't have to believe in the country. They just have to draw it well enough that the next person can tell whether they've arrived. The same page holds one of the strangest passages in this whole literature, and it has nothing to do with temperature. Further down the list, Sandberg takes up the objection you may have been carrying quietly for the past hour. Isn't there more to life than information processing? Doesn't a civilization that reduces itself to computation, however efficient, miss the point of being alive? And he concedes something, some theories of value, he says. Care about how a thing is done rather than what it leaves behind. Maybe a perfect Zen action holds value all on its own. The act complete in itself, needing no product and no witness. Then he follows that thought one step further than almost anyone would. If a perfect action leaves the world exactly as it found it, if the start state and the end state are the same, then an infinite number of such actions could be performed. and an equal amount of value achieved. And there would be no way of telling whether they have ever happened. There will not be a memory of them occurring. Hold that beside the quiet sky for a moment. A universe in which nothing seems to be happening might be a universe in which nothing is happening. Or it might be full past counting of perfect, completed, traceless acts, each one finished and folded away, without a mark left anywhere to say so. From the outside, the two universes look identical. That is not a claim about our sky. Sandberg doesn't offer it as one, and neither will I. It is just how far the idea opens if you let it. Even the emptiness has more than one reading, and some of the readings are full. And if that sounds like a cold philosophy, from a man who spent a paper pricing thought in units of forgetting, the same page carries his answer to that too. Falling in love, he writes, means that a mind goes from one state to another in a very complex way. He doesn't mean love is merely information. He means the traffic runs the other direction. The things we care most about are changes of state, and changes of state are exactly what the whole night's argument has been pricing. Nothing warm was ever outside the physics. The physics was about the warm things all along. There is one more piece of the story, and it is the ending the story actually has. All three authors, on the paper's first page, list the same institute among their affiliations, the Future of Humanity Institute at Oxford. It was founded by Nick Bostrom in 2005 to think about exactly this kind of thing. The long view, the far horizon, what a civilization ought to do with its trillion years. In the spring of 2024, Oxford closed it. The website came down and was replaced by a short statement, and the statement spoke of increasing administrative headwinds. The institute where people worked out how to wait for the end of the universe lasted 19 years. I'll say that once and leave it, because it doesn't need help. The people are fine. They write, they argue, they carry the questions elsewhere. Ideas keep better than buildings. But somewhere in the distance between 1 trillion years and 19 is an honest measurement of us, of who gets to think about the very long run, and for how long before something shorter needs the room. The paper's title, by the way, was borrowed. That is not dead which can eternal lie. It is a line of Lovecraft's from horror, and it comes in two authentic versions. The original from 1921, and with strange aeons death may die, and the more famous later form, which adds a single word, even death. The paper closes on the later one. 3 researchers dressed their argument in the borrowed clothes of cosmic horror, and then spent every page arguing the opposite of horror. That whatever sleeps in the dark, if anything does, is not monstrous, it is patient. On their account, the dark holds no teeth at all. At its strangest, it holds appointments. And before it ends, the paper does one last thing, the thing that lifts it clear of every armchair answer to the silence ever offered. It says how you could tell. If someone truly is saving the universe for later, then matter that escapes for good is money off the estate forever. Gas flung into the void between galaxies, mass locked away down black holes. A careful sleeper would move to stop the leaks. And the largest leak in the sky comes with a size attached. Stars more massive than about 25 suns. which burn out almost immediately as stars go and collapse into black holes, taking everything they were out of circulation for good. The paper works out that preventing them is feasible, cheap, by the standards of anything that could want to, by seeding the star-forming clouds with dust, about 100,000th of a sun's worth each year. So the clouds fragment into smaller, thriftier stars instead, and it names the signature that gardening would leave, a suppression of starbursts and of the heavy blue-white stars. That is a prediction. It stands in the paper in plain sight, and it is standing still. If the strong form of the hypothesis were true, if something frugal were already husbanding this corner of the universe, the great blue-white stars should be scarce, and the starbursts damped, and the sky quietly tidied. And the paper reports itself in its own closing pages. We do not see this. The starbursts proceed wherever surveys look. The blue-white giants are everywhere, brief, extravagant, pouring away in a few million years what a patient mind would hoard past the end of everything. Nobody is seeding the clouds. Nobody is damping the bursts. The authors of the Aestivation Hypothesis went looking for their sleeper's fingerprints on the sky and wrote down honestly that the strong version of their own idea fails its own test, which lands somewhere lovely if you remember where the critics finished. The men who took the great sleep apart ended on a hope about the view. The paper they were dismantling had already, 2 years earlier, gone out and counted, and the stars are not a few, and they were not left. They are all up. Every light in the house is on. Some of them you can check yourself. On a clear night in the winter sky, the 3 stars of Orion's belt are that kind of star. Hot, blue-white, enormous. The very sort a saver would have prevented. They are still there. Anyone can look. One question the night leaves open, and I'll name it and let it stand. The old one from the turn of the millennium about the alarm clock. Whether anything that lies down for that long can trust anything else to wake it. The paper, as far as I can find, never answers it. The servant is still climbing the mountain every 100 years. The ravens, as far as anyone knows, are still circling. So this is where it rests. A hypothesis its own author does not rank first. An objection whose authors concede their model may be too crude to decide the matter. No reply, no verdict. A few careful people writing to each other in the dark, disputed and unresolved. And honestly so, on both sides, which is rarer than being right. But something does survive all of it, and it is the thing you can keep. You have heard the silence of the sky your whole life as an emptiness, a room nobody came to. It can also be heard as a duration. Not nothing there, nothing yet, not an abandoned house, an early hour, long before anyone is expected to be up. Patience, it turns out, can be written in physics. Whether anything is actually practicing it, nobody knows. That is not a failure of the night. That is the finding. The blue-white stars are still burning. All of them, everywhere anyone has looked, spending themselves at a rate no patient thing would allow. Whatever the silence is, nobody has turned the lights down. Maybe there is no one. Maybe they are very far away. Maybe, thin, strange, still standing in a journal. Nobody has finished arguing with, "The quiet is only what patience looks like from outside." The sky doesn't say. It has been, by its own clock, a warm afternoon for 13 billion years or so, and everything that has ever happened has happened in it. The long cold evening, the cheap and endless one, hasn't started yet. The stars are up. The sky is quiet. It just stays open and waits.